Today we're going to talk about right triangles. So essentially, and we're going to be talking about trigonometry. Right triangle trigonometry is where you have two angles, like so, and they have a common endpoint. Usually this is called the vertex, and this is the angle. Now, what we learn in math is that there are two types of ways to, I guess, distinguish this. The first way is called radians, and the second way is called degrees. And so just ignore this unit circle, by the way. The first few problems we're going to do is we're just going to try to convert degrees to radians and radians to degrees. So I'm just going to erase this actually. And a helpful trick that I kind of learned is that when you convert, let's say, radian to degrees, what you do is you essentially just get the radian, let's say we're doing pi over 9. So you just do like pi over, let me move this down, pi over 9, and then you just times it by 180 over pi. So, and that will give you the answer. The same thing if you do degrees to radians. You just basically take like whatever degree you have, like I don't know, 90, and then you just multiply that by pi over 180. Um, to think of it in an easier way, what you're trying to do is you're trying to like cancel out these. So like the degrees and then like the radians or like the pi. So I'm just gonna like write this again, and this will just be like a reminder that we could like go off of. So let's just write it in red so we don't get confused. 32 degrees. Take what you have, times it by 180 over pi. If you do degrees to radians, then that's just going to be whatever you have times pi over 180. Okay, so let's do a few practice problems. I'm going to do similar problems from the homework, and let's see if we could complete them. Okay, so I'm actually going to move this really quickly. So we're just going to move this down here so it's not confusing. Okay, let's just do number one. Okay, so let's see. Let's do, we want to convert 18 degrees to radians. So all we're going to do is we're going to go over here, degrees to radians. That's this one. Do 18 times. Now, if you want to convert it from degrees to radians, that means we want to have the 180 on the bottom so we can get rid of it. So, because this is little degrees right there. So 180 degrees, and then pi is going to be at the top. And then you could also think of this as like a 1 just to make it easier. I don't know. But then you just 18 times pi. 18 pi over 1 times 180. That gets rid of the degrees, and then I'm pretty sure you could simplify this, and this would be pi over 10. And that's your final answer. So it's pretty simple. We could do another one. Let's see. Let's convert 33 or 330 degrees to radians. Same thing. We're just gonna do 330 degrees times, we want to get rid of that degrees, 180 And then on top we have pi. And then you could simplify it now. I do it at the end. I don't know if that's easier, but so basically we get rid of the degrees. 330 pi over 180. You could divide it by 10 at least to just get 30 over 2 pi or 18. And then we could, I believe we could divide by 3, and that will get us 11 pi over 6. And that should be our final answer. And then what I'm doing is I'm just like using my calculator to see if like 3 could to be divided evenly to both numbers, or 2, or like I just try to see like which two numbers will work, and then that's what I use. Then we could just easily do a different one where we do the opposite. So let's see. Let us convert 11 pi over 9 2 degrees. So 11 pi over 9 times, we want to get rid of pi, so we're going to have that on the bottom, and then on the top we're going to have 180. This gets rid of pi, and then we're going to do 1980 degrees over 9, which gives us, okay, this is much better, 220 degrees. And that should be our final answer. Last one, we could do, let's see. Okay, we'll do this one. We'll do convert -2 pi over 3 to degrees. Okay, now this should be relatively easy. We have pi on the top. Gonna get rid of it. It's 80. Get rid of those. Let's see. 2 times 180 divided by 3 is gonna be, because we have the negative, negative 120 degrees. Okay, so that was the first half of 8.1, and next we're gonna do, so for this section, we also want to learn our main trig functions and the reciprocal trig functions, so the main ones. So basically, you have sine, you have cosine, and then you have tangent. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. So these are your main ones. These are the reciprocal ones. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. I just abbreviate that. And then tangent is opposite over, make sure that homework doesn't close for me, opposite over adjacent. Let me just check if that's right. Okay. So you're gonna need to remember this, and it's easy to remember the reciprocal ones because it's literally just flipped. So if you just memorize these ones, then you will know cosecant, secant, and cotangent if you have a question on that. So just remember this, SOHCAHTOA, sine, cosine, tangent, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay. So for these set of problems, we're going to find the trigonometric ratio. And for the homework problems, they actually give you a picture, which is helpful. So we are given this picture. 34, 16, 30. Alpha, beta. And so what they want us to find is cosine of alpha. Okay, so the first thing you want to do is label which side is which on the triangle. So to find the hypotenuse, all you do is you find your right triangle, you go directly opposite. This is your height. The next thing you want to do is find your opposite. And to do that, you're just going to find what angle you're given. So we're trying to find alpha. So we're going to use this angle and go opposite of that. That is our opposite. And then because we have three angles, we already discovered two. The last one is just going to be our adjacent. Oh, that's, you know what I mean. Okay. So if we look up here, we said cosine is adjacent over hypotenuse. So for cosine of alpha, we're just going to find our adjacent, 30, over our hypotenuse, which is 3. We could divide both by 2. It's going to be 15 over 7. And that's it. That's your answer. So remember SOHCAHTOA and how to find your hypotenuse, opposite, and adjacent. Okay, let's do another problem. Let's see, let's just go over here. Okay, so our next problem is we're gonna find secant of beta. And we are given this, oh man, triangle. Okay, where we're doing a triangle. Angle, alpha, beta, 35, 21, 28. Okay, so same thing, but we're using secant. So if we write down SOHCAHTOA, remember that secant is the reciprocal of cosine. So we're going to be looking at this one. But for secant, we're actually going to be doing hypotenuse over adjacent. For secant of beta, that's just going to be our hypotenuse, which let's see if we could try to remember. How do we determine that? We look at our right angle, we go opposite to that. So this is going to be our hypotenuse, and then we do our given angle, which this time is beta instead of alpha. So we're going to go opposite to that, and then this one is going to be our opposite, and this one's going to be our adjacent. So circle them to make it easier, I guess, to read. And then we're going to do our hypotenuse 35 over our adjacent, which is going to be 21. So I'm pretty sure both of these can be divided by 7, and that will get you 5 over 3. 0.1. That's it. Okay, so basically to recap is we talked about angles, we talked about 2 types of angles, radians or degrees. We talked about converting radians to degrees and vice versa and how to do that. And then we talked about the main trig functions and the reciprocal trig functions. We talked about a way to kind of remember. Sine goes with opposite over hypotenuse, cosine goes over adjacent hypotenuse, etc., etc. And we did some problems where we were able to find a given angle based on the figure that was given to us, which is a right triangle. And yeah, that's it.